In this question, we have got two questions and we can solve any one among this in the exam. Now let's start with the first question here. In this question, they have asked us to first find out A inverse, and using that A inverse, they have asked us to solve the system of linear equations, where A is the matrix. So now let's start with A inverse. A inverse is given by 1 by determinant A into adjoint A. Now, in order to find out adjoint A, I need to find out cofactor matrix of A. So I'll take out cofactor of A is equals to, I'll take plus, minus, plus, minus, plus and minus, plus, minus and plus. This is the alternate plus minus that we have to take for cofactor. And I'll start with the first element. For first element, we have got 36 times 18 minus 5 times of negative 2. 18 minus of minus 10 is going to be 18 plus 10, which is 28. Now the second element, it is going to be 26 times 12 minus 5 times 25. So 12 minus 25 is going to be negative 13. So I'll be left out with negative of negative 13 here. Next, the third element, 2 negative 2 times is negative 4 minus 3 5 times 15. So negative 4, negative 15 is going to be negative 19. Next, the second row, if I'm going to ignore this, I'll be left out with negative 1 times 6, which is minus 6, minus 4 minus 2 times is going to be minus 8. So minus 6 minus of minus 8 is going to be plus 8, so which will be plus 2. Next, the second element, I can take this out as 5 6 times 30 minus 5 4 times 20. So 30 minus 20 is going to be 10 minus, next the last element of second row, which is equals to 5 minus 2 times is minus 10 minus 5 minus 1 times minus 5. So minus 10 minus of minus 5 is going to be plus 5. Minus 10 plus 5 is equals to minus 5. Now let's look into the elements of the last row. Here we have got 5. With this I could say minus 1 times 5, which is minus 5, minus 4 3 times 12. Minus 5 minus 12 is equals to minus 17. The second element of the last row, we'll get 5 5 times 25 minus 14 times 8. 25 minus 8 is going to be 17. Next, the last element, 5 3 times 15 minus of 2 minus 1 times is minus 2. So 15 minus of minus 2 is going to be plus 2. 15 plus 2 is 17. So this is the cofactor. Now I need to find out adjoint. Now adjoint is nothing but the transpose of this cofactor. So I'll take this out as 28, 13, minus 19, and minus 2, 10, and plus 5, negative 17, negative 17, and 17. Now let's find the value of determinant A. Determinant A is equals to 5 times of 28 minus of minus 1 times of minus 13 plus 4 times of minus 19. So whatever the values you have taken for cofactor, you can take it and solve determinant A. Now this is equals to 528 times is going to be 140. Minus of minus is going to be minus 13. Minus 419 times is going to be 76. So 76 plus 13 is going to be 89. 140 minus 89 is equals to 51. With this, I can say A inverse is equals to 1 by 51 times adjoint A, which is equals to 28, 13, minus 19, minus 2, 10, 5, minus 17, minus 17, and 17. This is our A inverse. Now, with the help of this, they have asked us to solve the equations here. So where I can say it is of the form AX is equals to B. where x is going to be x, y, and z, and b is equals to 5, 2, and minus 1. With this, I can take x is equals to A inverse of b. Now I'll take x is equals to A inverse, which is nothing but 1 by 51 times of 28 minus 2 minus 17, 13, 10, and minus 17, and minus 19, 5, and 17. Now this has to be multiplied with 5, 2, and minus 1. Now let's simplify this, which is going to be 1 over 51 times of 28 5 times is going to be 140, minus 2 times is going to be minus 4, minus 17 times minus 1 is going to be plus 17. So on simplify 140 minus 4 plus 17, we get 153 as the first value. Next, I'll take 13 5 times, which is 65, plus 10 2 times, which is 20, minus 17 times minus 1 is going to be plus 17. So 65 plus 20 plus 17, I'll get this out as 102. Next, the last row, minus 19 5 times is going to be minus 95, plus 5 2 times is 10, and 17 minus 1 times is going to be minus 17. So we'll get minus 95 plus 10 minus 17 is going to be minus 102. So on dividing this, I'll get 3, 2, and minus 2. Now they're asking us to find out the value of x, y, and z. With this, I can say x is equals to 3, y is equals to 2, and z is equals to negative 2. This is our final answer. Now let's look into the next one. If x, y, and z are different, and they have given determinant of x, x square and 1 plus x cube, y, y square and 1 plus y cube, z, z square and 1 plus z cube is equals to 0, then using the properties of determinant, they have asked us to show that 1 plus x, y, z is equals to 0. Now let me start with LHS here. LHS is equals to determinant x, x square, and 1 plus x cube, y, y square, and 1 plus y cube, z, z square, and 1 plus z cube. Now using the properties of determinant, as we can see here in the last column, we have got two terms. We can split that as a two determinants, which is equals to x, x square, 1, y, y square, 1, z, z square, 1, plus the other determinant, which is x, x square, x cube, y, y square, y cube, and z, z square, z cube. So this is a summation of the previous determinant. Now with this, I can take this out as, I'll write the first determinant as it is, which is x, x square, 1, y, y square, 1, z, z square, 1. And as we can see here, we have put x common in the first row, y common in the second row, and z common in the third row. I can take this out as x times y times z. And we have got 1 x, x square, and 1 y, y square, and 1 z, z square, and they have told this is equals to 0. Now if I'm going to look into the first and the second determinant, it's exactly the same thing with its columns interchanged. So I can take this out as 1 plus x, y, z times of this determinant, which is x, x square, 1, y, y square, 1, and z, z square, 1, and this is equals to 0. Now on applying the row transformation, that is R2 as R2 minus R1 and R3 as R3 minus R1, I'll get 1 plus xyz times x, x square, 1. And here we have got y minus x and y square minus x square, and 1 minus 1 is 0. Z minus x, z square minus x square, and here we have got 0. And this is equals to 0. So on expanding this, I'll get 1 plus xyz times of, as we have got second row and third row ending with 0, I can directly take out the value here, which is going to be 1 times of y minus x times z square minus x square minus y square minus x square times of z minus x. Now this is what we have it inside. Now on simplifying this, I can say z square minus x square is z plus x times z minus x, and y square minus x square is y plus x times y minus x. And looking into this, I can see y minus x common here, and here also y square minus x square, we have got y minus x. And here we can see z minus x is also common, where z square minus x square is nothing but z plus x into z minus x. So I can take this y minus x outside and z minus x outside. I'll be left out with z plus x minus y plus x. So on simplifying this, x gets cancelled, and this is equals to 0. With this, I'll get 1 plus xyz times of y minus x times z minus x times z minus y is equals to 0. Now, as we know that x, y, and z, all three are different, I can say that y minus x will not be equals to 0, z minus x will not be equals to 0, and z minus y will not be equals to 0, as x, y, and z, all three are different values. So we have got only one option, that 1 plus x times y times z should be equals to 0. This is our final proof.